It is an early out day, so we'll get through as much as we can. Algebra 1, lesson 50, graphing inequalities. So we've graphed linear systems, right? We've graphed things like the slope-intercept form and things like that. Not a whole lot is changing here. The only thing that we're adding to this is inequality symbols. So instead of something being equal, things are not equal. Okay, something might be greater than something else, something might be less than something else. It could be greater than and equal to, or less than or equal to. Are we familiar with those terms? Because I feel like I taught that stuff even whenever I was back like teaching 7th and 8th grade math, right? I feel like this stuff should still be reviewed. Doesn't it feel like a lot of this class has been, I mean, we're like halfway through the year, and doesn't it still feel like a lot of it is review, a lot of it's little things that we've learned and that we've known, we're just kind of adding a little bit to it. Now, granted, I'm not saying that you haven't learned whole new things like working with exponents, right? Oh, I think a lot of that has been new. Things with like radicals or square roots and different types of roots has been new. But a lot of this stuff is kind of old. So linear inequalities in one variable is an inequality that can be written as something like ax is less than b, or ax is less than or equal to b, or ax just doesn't equal b. And you might see this symbol here from time to time. It's not used a whole lot, but it just means isn't equal to. Okay? It doesn't mean is greater than or even less than. It just means it isn't equal to it. Okay? So it's an excluded value in a set. So where a and b are real numbers. Okay, unlike equations, inequalities can have more than one numeric solution, right? And that's where we see on a number line, we see an arrow shoot across, right? Because it includes a lot of different solutions. It might exclude a solution. So we see a lot of that type of thing. On a coordinate plane, we'll see shading, right? We'll see shading above a line or below a line. Even overlapping inequalities and seeing darker shaded regions than other shaded regions. So the solution of an inequality in one variable is a value or set of values that are going to satisfy the inequality, something that allows it to be true. Okay? To determine if a value is a solution to an inequality, we substitute the value of the variable into the equation and then we simplify it down. If the inequality statement is true, the value is part of the solution set. If it makes the statement not true, it's excluded from the solution set. Okay? Equivalent inequalities are inequalities that have the same solution set. It's not always reasonable to list all the values in a solution set because, like we said, right, it might have more than one value. In fact, it might have an infinite number of values. In fact, a lot of these, most of them do. Okay? Instead, a graph on a number line can represent the solution set of an inequality. So the graph below shows, as you see, the endpoints of a solution set. I'm going to sneeze. I'm just trying to warn everybody right now. And what I found out is that if I talk about a sneeze I'm about to have, usually they go away because sneezes are really shy. Anyway, I'm glad that's been recorded. We can keep that for years and years to come. Remember that lesson where Mr. Wilcox talked about a sneeze. The graph shows the endpoint of the solution set as an open or closed circle. We're familiar with that, right? When is it closed? When is it that filled in circle? And how am I representing when it's included? How do I know when it's included? Right, so whenever I see something where there's a bar underneath my inequality symbol, right, that means also equal to, okay? So we see that with a couple of these here. All right, if it's just greater than or equal to, what kind of, what am I representing that? What kind of circle is it? Open or closed? If it's just greater than or less than, it's open. I might have said that wrong. Okay, a heavy line and arrow indicates, and you can't really see it very well because what I was using. All right, it should look a little bit more like that. You want to be able to see that arrow a little bit better than how it's shown here. Okay. So a heavy line and arrow indicates all values that are in the solution, and that arrow means it's going to continue to go on. Okay, that's why we wouldn't necessarily include a table of values, because let's say x is greater than 0. Well, how many values are greater than 0? A lot, right? So the table of values is going to go on forever, correct? Right? Or x is less than 0. How many values are less than 0? A lot, okay? And then we have x is greater than or equal to 0. So that's going to include 0 and everything that's greater than 0, right? X is less than or equal to 0. That's going to include 0 and everything less than. But here's an interesting one, is x does not equal 0. Well, what does that include? Everything that's not 0, right? So everything but 0. Even like 0.00000001 is included, but not 0. Does that make sense? Okay. So are we fairly familiar with what we're seeing up here? Is there a lot of new information for us? Well, okay, so I feel like, when we're grading our homework tomorrow, I should see very few, practice set questions that we've missed. So to create the graph of an inequality, first we create a number line. And you notice that I didn't fill in my number lines with a whole bunch of numbers. You should. It was just a matter of, where I wanted to put my time in. And so the very least that I needed to include was the number involved in inequality. All right, so you should include more numbers in your number lines. But first we want to create a number line that includes the endpoint. At the very least, it has to have the endpoint. I think your number line should always include 0, always. So 0 and whatever the endpoint is. Then determine if the endpoint is part of an open or closed circle. And finally, from the endpoint, we need to draw that heavy line with an arrow to show the solution. So it's got to be heavier than the number line, because you're drawing it on the number line. It needs to be thicker than that, okay? And it needs to go in the right direction. Now, if you want to make sure that your arrow is always going to go in the right direction, I don't know if anybody showed you this before, but if I put my variable on the left-hand side of my inequality, notice how x up here is always on the left, right? I see x is left of 0, 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 right? Do you notice that? All right. What's handy about that is then my inequality symbol is always going to point in the direction that my arrow should go. Notice that this points to the right, my arrow goes to the right. Notice here my arrow points to the left, my arrow goes to the left. All right? So, I don't want to write something where I'm writing, I would still get the same line, but if I wrote 0 is less than x, well, what I'm also needing to read that is x is greater than 0. My arrow would still go in the same direction, but it's not going to be as helpful. Does that make sense? So if I keep my variable on the left-hand side of the inequality, right, whenever I come down to my solution, if I'm not quite sure, I know that my arrow is always going to go in the same direction as how my inequality is pointing. Does that make sense? All right, anything I can show you to help you out, I want to show you. All right. So the graph of an inequality can be translated to symbolic form. First, identify the endpoint. If the endpoint is closed, the inequality includes that value and is represented using, either greater than or less than or equal to. Okay, what we see there. If the endpoint is open, the inequality does not include the value. It's an open circle. It's going to be just greater than or less than. All right, that's it for that. All right, so let's look at maybe a couple questions here. All right, it says which value is part of the solution set? All right, well, can we go ahead and solve for x in this? Jeremy, what would you do? We're on 1. We want to solve for x. Add 13 to both sides. Okay. All right, what's negative 9 plus 13? Okay, so I got 1/2 x. Oh, not equal to. Okay, but greater than 4, right? Okay, now what do I want to do? Multiply by, no. You're right to multiply, but notice it's 1/2 times x, so usually I would divide, right? But it's a fraction. I can't divide by a fraction, so I multiply by the reciprocal. What's the reciprocal to 1/2? 2 over 1 or 2, right? So we're going to multiply this by 2, and we're going to multiply this by 2. So x is greater than what? Huh? 8. Okay, x is greater than 8. Now, does it include 8? Is 8 included there? Right? So if I was to draw a number line, I'd have 0, I'd have 8, I'd have a circle around 8, and I would be going to which direction? Left or right? Right. Okay, that's the most basic number line I'm going to draw. So now that we have that, all right, I'm going to go ahead and erase the rest of this because we've got answers around here. Is negative 8 included? Nope. What about negative 15? What about 8? No. Why is 8 not included? It's an open circle, right? So is 15 included? Yeah, 15 is part of the solution. And I can check that by plugging 15 in for x. 15, is 15 greater than 8? Yeah. You know, I could go through the rest of these. Is 8 greater than 8? No. Is negative 15 greater than 8? No. Is negative 8 greater than 8? No. So I'm looking for the thing that is true. Does that make sense? Okay. All right. Let's see. What time are we out of here? 31. So let's do one more from here, and then we'll do one from your homework. All right. Tell whether 6, 9 is a solution. All right. Notice how we have x and y. This is a linear inequality. How would I check that to see? Christian, what do you think you'd do? We're on number 2. How could I tell if 6, 9 was a solution? Does anybody know what the catchphrase to Glade, you ever see those Glade air fresheners, right? What's the catchphrase for those things? I don't know what like the commercials, what they always say at the end of the commercial. No? Jeremy, do you know? Yeah, they call them Glade plugins, right? So it's, what do they say at the end of the commercial? Plug it in, right? All right. I'm not just saying this just to fill time while Christian figures it out. That's your answer. But in terms of what do we use the Glade plug-in phrase, which is plug it in, right? But what am I plugging in? No? Tiffany? My x and y values into my equation that has an x and a y, right? I'm going to plug my x value into the x spot in the equation. I'm going to plug my y value into the y spot in the equation. So if my equation is y is greater than 5x plus 1 and I want to rewrite that, what am I plugging in for y? Okay, Christian, I'm going to write 5. What am I plugging in for x? 6. All right, I'm going to solve. We got 9 is greater than something. What's 9 times 6? 5 times 6. 30. And what's 30 plus 1? Is 9 greater than 31? No. So is 6 not a solution? No. Okay. Or I guess, yeah. I mean, that's my answer. Okay, do we see how to do that where we can solve for a coordinate in a linear inequality? Okay. All right. Here we should be able to look at this real quick. I mean, you can actually look at 3 and 4 pretty quickly. The inequality is x is less than 4. So is this an open circle or closed circle? Open circle. Where is that open or closed circle going to be? At 4. All right, so we automatically know that those two are wrong, right? Because they've got closed circles at 4. which direction should the arrow go? To the left, all right? So A is my answer, right? That's pretty easy. All right, let's take a look at your homework. Okay, take a look into there and see if there's a question that you would like some help with. Okay, if nothing pops up, you guys get the rest of the time to work on some homework. Give you about 5 more seconds to see if there's a question there that it doesn't have to be Jeremy. It's usually Jeremy, but it doesn't have to be. 2? All right, 2. And these seem to be common to us, right? That we kind of seem to struggle with these, maybe, or at least we're afraid of them. All right, so we've got m x to the 4th y squared minus m squared x cubed y cubed plus 5m squared x to the 6th y squared. All right, and it says factor. Okay, factor. We want to take, it says find the greatest common factor. All right, so let's talk about constants. What is the constant or the coefficient here to this first set? What's the number out front? 1. Okay, what's the number out front of the second set? 1. What's the number out front of the third set? 5. What's the largest number that will go into all 3 of those numbers? 1. Okay. All right, now let's look at the m's. Right, what's the largest m value that will go into all of them? M squared will go, I mean, how, right, because my first set only has m to the first, right? If we have to, let's go through, is that the only place that doesn't have an exponent for a variable? Okay. All right, so the biggest m that I can put into all of them is just m, right? Okay, what about x's? I've got an x to the 4th, I've got an x cubed, I've got an x to the 6th. What's the biggest x that will go into all of them? X cubed. Okay, good. What about y? I have a y squared, a y cubed, and a y squared. What's the biggest y value that will go into all of them? Y squared. Okay, we've got m, we've got x cubed, we've got y squared. Now what they want me to do is they want us to show that we've taken those out because we're factoring out. Okay, so what I'm left with on the inside, okay, if I've taken an m out, do I have an m from the first set left? No. All right, I've taken x cubed out. How many x's do I have left in the first set? I have 2 left. I've taken out an x cubed. This is an x to the 4th. What do I have left? Just x to the 1st, right? Do we understand that, Tiffany? Okay. I've taken out a y squared. All right, let's go back to the first set. Do I have a y left? No. Okay, so I just had that x. Okay. Let's see. Don't have to worry about that necessarily. All right, so you're going to go down through here. I took out an m. I still have an m left, but it's a minus m. I've got to include that minus. Okay. I took out an x cubed. There's no x's left. I took out y squared. There's a y left. Right. I'm left with a 5. I've got an m left. Right. I've got x cubed left, but I don't have any y's left. So my final answer should look like that. Okay, does that help you out? Okay, and you really don't even have to include this 1. All right. You guys have a great day.